Hello viewers, welcome to video number 72 of the channel Chemphilic, and video number 72 is the 14th episode of chemical thermodynamics, and the topic of this 14th episode of chemical thermodynamics is relation between heat of reaction at constant volume and constant pressure. So let's start. We know that heat exchange at constant pressure Qp is the change in the enthalpy, whereas heat exchange at constant volume is equal to the change in internal energy, and relation between them is Qp is equal to this delta H, that will be is equal to delta E plus P delta V. This we have got it from first law of thermodynamics. This relation we know. Now suppose a reaction where the reactant and products all are gaseous. That means molecules of the reactants and products are all gaseous. Okay. Then let Nr is the number of moles of reactant. Okay. And Np is the number of moles of product. Therefore, Np minus Nr, this is equal to, sorry, I write again, Np minus Nr, this is equal to delta N, that is change in the number of moles as a result of reaction. Now let V is the volume of 1 mole of reactant, 1 mole of reactant at a fixed temperature and pressure. Okay. And what we have assumed that reactants and products are gaseous. V is the volume of 1 mole of reactant at fixed temperature and pressure. So therefore V into delta N, that will be the change in volume that is delta V due to reaction. Okay. Now what we have seen that delta H is equal to delta E plus P delta V, and delta V just now we have seen that is equal to V into delta N. So delta H we can write it as delta E plus V, sorry, this P is there, PV, then delta N. Now we know that PV is equal to RT PV is equal to RT for 1 mole. So, in this case, what we can write? Delta H is equal to delta E plus RT delta N. So, this is the relation between this heat of the reaction at constant volume and constant pressure. What is heat of the reaction? In my earlier video already I told you, heat of the reaction is the enthalpy change at constant pressure, that is the enthalpy change, or that is the difference of the enthalpy of the product and reactant. So, heat of the reaction at constant pressure, this is means constant pressure, that is the, what is that? Enthalpy of the product. Heat of the reaction means change in enthalpy during reaction. Enthalpy of the product minus enthalpy of the reactant. And heat of the reaction at constant volume, that is delta E, when the reaction occurs constant volume, then also this internal energy of the product minus internal energy of the reactant. So, this is the relation between the heat of the reaction at constant pressure and constant volume. There are two relations, right? Now, just imagine that, let us consider one case where the reactants and products, they are solid or liquid. So, when reactants and products are solid or liquid. Say for example, this sodium hydroxide aqueous solution, that means liquid solution, plus hydrochloric acid aqueous solution, that will give the, this is sodium chloride aqueous, that means solution, plus water. In this case, what happened during the reaction? These are both in the solution, reactants and products. In this case, what happened when these reactants and products are solid or in the liquid state? Then change in volume, that is delta V is negligible. Delta V is negligible. So, if delta V is negligible, you look at this equation, then what we can write? Delta H is equal to delta E, because delta V, here delta V is almost 0. So, delta H is equal to delta E. That means the heat of the reaction at constant pressure is equal to heat of the reaction at constant volume. Now let us take another case. Say here, this reaction, carbon solid plus oxygen gas, that will be the carbon dioxide gas. Okay. Here all are gases, right? Not all are gases, sorry, carbon is solid. Okay, these two are gases. But when we will calculate the change in the number of moles, we have to consider only the gaseous substance. So here delta N, change in the number of moles, which is the number of moles of the product minus number of moles of the reactant, that will be equal to, this is 1, this is also 1, 1 minus 1 is equal to 0. Solid one we should not consider. In that case also, we know delta H is equal to delta E plus delta N RT. So here delta N is equal to 0. So delta H is equal to delta E. That means heat of reaction at constant pressure is equal to heat of reaction at constant volume. So heat of reaction at constant pressure, it is the change in enthalpy or delta H. Heat of reaction at constant volume is the change in the internal energy or delta E. And this heat of the reaction at constant volume and constant pressure, this is one relation. Delta H is equal to delta E plus P delta V, and then we have derived another relation between them, that is delta H is equal to delta E plus RT delta N, where delta N is the change in the number of moles as a result of the reaction. And we are considering that these reactants and products are gaseous molecules. If the reactants and products are suppose solid, liquid or in the solution, change in the volume is negligible, that is delta V is negligible. In that case, heat of the reaction at constant pressure will be equal to heat of the reaction at constant volume, because this delta V is 0. And in this case, what we have observed, if the change in the number of moles is 0 after the reaction, here carbon is solid. Solid one we should not consider. We have to consider the number of moles of the gaseous reactant. So here change in the number of moles is 0. So delta N 0 means from this equation we can write that heat of the reaction at constant pressure is equal to heat of the reaction at constant volume. So this is all about the heat of the reaction at constant pressure and at constant volume. Hope you have understood. Thank you.